Hello, this is Chris from the Motion Bench. Before we get started, a quick disclaimer. This video is not sponsored or influenced by anyone. I purchased all of the hardware you'll see in this video myself at full retail price. Everything shown here is part of my own independent evaluation. Today, we're taking a deep dive into the BigTreeTech EBB36 Gen 2. On the screen right now, I have the EBB36 Gen 1 on the left, and on the right, I have the EBB36 Gen 2 along with the included USB adapter board. So as I go through the comparison, you'll know exactly which board I'm referring to. This is a brand new release, and it builds on the EBB36 architecture that's already been popular in Klipper builds. One of the biggest differences right away is communication flexibility. With Gen 1, the board you see here on the left, it was CAN by default. If your main board didn't support CAN natively, you had to purchase the separate U2C USB to CAN adapter to communicate over USB. With the Gen 2, shown here on the right, BigTreeTech includes both the toolhead board and the USB adapter in the same package. So you have everything you need regardless of which mode you choose. You simply change a jumper on the board to switch between USB and CAN mode. Now, if you plan to run CAN mode directly from a main board that already has native CAN support like an Octopus Max EZ, you don't need the USB adapter long term. However, there's something important to note. If you're wiring it directly for CAN, you'll need to cut the MX 3.0 end off of the included cable and terminate those wires yourself to your main board's 24-volt power, ground, and CAN high and low pins. It's not that difficult, but it's something you should be aware of before installation. Now, let's talk hardware differences between Gen 1 and Gen 2. First, the extruder motor connector. On Gen 1, it's pointed straight up. On Gen 2, it's rotated 90 degrees. It seems minor, but it makes cable management much cleaner. Fan headers have also been updated. Gen 1 had two 2-pin fan headers. Gen 2 has the same two 2-pin fan headers, but it also includes a 3-pin fan header with a tachometer pin. On Gen 2, you can configure each fan header independently for 5-volt or 24-volt. There is no 12-volt option, so keep that in mind when selecting fans. Thermistor support has been simplified significantly. On Gen 1, you had a dedicated 2-pin NTC thermistor header and a separate 4-pin header for PT100 or PT1000 sensors. If you wanted to use PT100 or 1000, you had to configure tiny micro switches with tweezers to set it correctly. On Gen 2, that's streamlined into a single header that automatically switches between NTC or PT1000. Connector size overall has been reduced on the Gen 2. Everything is more compact except for the motor connector, which remains the same size. The power connector style has also changed. Gen 1 uses an MX 3.0 connector directly. Gen 2 uses an XT30 connector on the board itself while still using an MX 3.0 connector on the USB adapter. They also include an MX 3.0 to XT30 cable in the box. Gen 2 also includes a breakout header that allows you to expand USB or CAN to additional devices. For example, something like the cartographer surface scanner can be connected regardless of whether you're operating in USB or CAN mode. Just keep in mind that if you're operating in USB mode, the breakout header will only support USB devices, and conversely, if you are operating in CAN mode, then it will only support CAN devices. Now, there is a difference between these two boards when it comes to resonance compensation. On the Gen 1, you have the older, far more documented and widely supported ADXL 345, whereas on the Gen 2, you have the newer LIS 2DW. Now, let's talk documentation because this is where I have some criticisms. The Gen 2 documentation is noticeably lacking compared to Gen 1. For example, the pinout diagram does not properly label the extruder motor MCU pins. It only shows A2, A1, B1, and B2 at the driver level. If you want the actual pin assignments for Klipper, you have to dig into the example configuration file. You're probably going to do that anyway, but if you're like me, where you already have a Klipper config and you're just updating it using the pinout diagram, you might not think to go look into the example configuration to get the motor pins. It would be nice if they included those on the pinout like they do everything else. This can basically be stressful for new users who aren't sure if they're configuring things correctly. More importantly, the flashing and setup documentation is incomplete. Dare I say it's non-existent. If this is your first EBB board, you're very likely going to struggle. Unlike Gen 1, which is heavily documented, the Gen 2 leaves much of the flashing process up to you to figure out. This can lead to confusion, frustration, and potentially people returning the board simply because they couldn't get it configured. That said, this is a brand new board release, and I genuinely hope BigTreeTech improves the documentation over time. The hardware itself is solid. The Gen 2 is built off of the same architecture as the Gen 1 version 1.2, which utilizes the STM32G0B1 microcontroller as well as a TMC2209 motor driver. But the documentation itself needs refinement. To help bridge that gap, I'll provide step-by-step written flashing instructions in the video description below. You'll be able to copy and paste the necessary commands for flashing Catapult or Klipper directly. Speaking of flashing, regardless of which mode you plan to use long-term, you'll initially need to use the USB adapter to flash the board using DFU utility. You can flash the Catapult bootloader first, which I highly recommend because it'll make updating in the future easier, or you can flash Klipper directly without a bootloader offset. I personally don't recommend this because anytime you want to upgrade Klipper in the future, you're going to have to break out the USB adapter, so on and so forth. Catapult makes that whole process a lot easier, especially if you're running a CAN board without the USB adapter board. Both methods work, it just depends on how you want to manage firmware updates moving forward. Moving on, if you're running CAN and adding additional CAN devices, like I will be with a Cartographer V4 surface scanner, remember your termination rules. If the EBB36 is the last device in the CAN chain, make sure that you enable the CAN 120R termination jumper. If it's not the last device, leave it disabled. Only the physical ends of the CAN chain should be terminated. Overall, once configured, the Gen 2 has been stable in my testing. It builds on the strengths of the Gen 1 platform, simplifies thermistor configuration, improves flexibility, and adds cleaner integration options. The hardware is strong, it just needs better documentation support. Now, let's move on to flashing and testing the EBB36 Gen 2. One thing I wanted to cover before I start the flashing and configuration process, what you see here are two different cable connectors. The one on the left here is the one that comes with the EBB36 Gen 2. It has the XT30 connector on the one end and the MX 3.0 connector on the other. If you're running in CAN mode without the USB adapter board, you'll have to cut off the MX 3.0 end and pin this out directly for power, ground, and your CAN high and low yourself. That being said, one thing that I should also point out is that regardless if you run in USB or CAN mode and you want to test switching back and forth between both of them, you can go ahead and cut the end of the MX 3.0 end off of this and simply don't use this connector here. You can connect your CAN high-low or USB data pins here. They're going to be the same, it just depends on what you set at the jumper board. And then you can run your power and ground off of this header here. So there is flexibility with this. Just know that for CAN bus without the USB adapter board, you will have to cut the cable or provide your own. If you have an existing XT30 cable like I have here, you won't need to cut the one that comes with the EBB36 Gen 2. Now, without further ado, let's go ahead and get into flashing the Catapult bootloader and then Klipper firmware. So what we're going to do is we're going to connect all of this together. We're going to go through the flashing process on screen, and then once that's all complete, I'll connect this instead, and then we'll go into the Klipper configuration and test everything out on the hardware side. All right, in order to flash Catapult and then Klipper, we have to start connecting hardware. I have my Octopus Max EZ board here, my power supply, and my host machine. From there, I've got my USB adapter board connected to 24-volt power on my power supply. I've got USB connected, and I've got the MX 3.0 to XT30 cable connected to the EBB36 Gen 2 board itself. Okay, in order to flash Catapult, we need to press and hold the boot button, then press and release the reset button. Once you do that, you can release the boot button and you should see a red LED light up on the board. This puts it in DFU mode. Now, if we go over to our terminal here, and then you'll see on the left side here, I've got an entire list of commands. I will copy and paste this into the video description below. But the first thing that we need to do is SSH into our host machine. You'll probably be using a Raspberry Pi 3 or 4. I'm using an Intel NUC with Linux installed and everything set up. We're going to go ahead and clone Catapult, and then we'll cd into the Catapult directory, and we're going to type in make menu config and press enter. First thing we need to change is the microcontroller architecture. So we press enter, highlight STM Electronics STM32, and press enter. From there, we need to change the processor model. In our case, it's the STM32G0B1. Press enter. Clock reference 8 MHz crystal, which is selected by default. Communication interface. We want to change this. In our case, we're going to change this to CAN bus on PB12 and PB13. If you're using USB, you'll set this to USB on PA11 and PA12, which is enabled by default actually. So CAN bus on PB12, PB13, press enter. Application offset, 8 kilobyte offset, By default, it will be set to 1 million CAN bus speed. If you did not change this when originally configuring CAN bus on your host and Klipper side, then leave that value alone. Another important thing to note here is to ensure that support bootloader entry on rapid double click of reset button is enabled. From there, we can press Q to quit, press Y to save. After saving our menu config, now we need to type in make and press enter. This is going to build catapult specific for our EBB36 Gen 2. Once that's finished, we need to get our device ID. Now by default, this should be the same for everyone. Just type in this sudo dfu-util-l to confirm. And what you're looking for is this address right here. Again, this should be the same for everyone. There's 0x08 and then 6 additional zeros. This is the only thing that you need from this list of output. You can ignore everything else. From there, we're going to copy and paste our next command. Sudo dfu-util-a0-d.2 catapult.bin file that we just made. Defuse address is that 0x08 with 6 additional zeros, :force, :mass -erase, :leave. And then you can press enter. And you're going to see a bunch of text here. The only thing that you're looking for is file downloaded successfully. From there, we can physically unplug the board. And now, if you are using CAN mode, you're going to add 2 jumpers. This jumper here is to switch from USB to CAN mode. And then this jumper next to it is to enable the 120R termination, because at the moment, this is the last device in my CAN chain. And now, what I can do is go ahead and hook this up directly to my Octopus Max EZ. I can now get rid of this USB adapter board. It will no longer be needed. And then from there, we'll go ahead and flash Klipper. Okay, now we've simplified our hardware setup. We've got our XT30 cable that runs to the CAN bus pin on our Octopus Max EZ. And then we've got 24 volt power and ground hooked up directly to the power supply for this video. All right, now my hardware configuration is set up for CAN bus. Again, if you're using USB mode, then you don't have to set it up this way. You can keep it connected the way you saw it previously with the USB adapter board plugged in through USB with your 24 volt power and ground coming off your power supply. And then from there, to prepare us to be able to flash Klipper, we double tap the reset button, and that will put it into the catapult bootloader mode, which we're going to need later. From there, let's clean up our screen over here. And the next thing is we're going to CD into Klipper. We're going to type in make clean just to make sure that there's no pre-builds there that might, interfere or mess anything up. From there, we're going to type in make menu config. On here, we're going to enable extra low-level configuration options, microcontroller, STM32, processor model, STM32G0B1, bootloader offset, 8 kilobyte bootloader, clock reference, 8 megahertz crystal, communication interface. By default, it's USB on PA11, PA12. If you're using USB, you can leave this value alone. But again, I'm using CAN bus, so I'll change this to CAN bus on PB12, PB13. CAN bus speed, once again, this is 1 million by default. If you don't know what you're doing, leave this value alone. It's very important to ensure that all your CAN bus devices and configurations use the same CAN bus speed. Otherwise, you're going to run into timing errors and all other kind of headaches. Once we configure that, we will press Q to quit, press Y to save, and now Klipper is configured to build for our EBB36 Gen 2. We type in make, press enter, wait a few seconds for it to compile, and complete. And we can clean up some of the mess on our screen. Step 4, we're going to flash Klipper. So first and foremost, we need to CD back into Catapult and then into the scripts directory. From there, we're going to use this Python tool to get our CAN bus ID. So it's Python 3 flashtool.py-i can0-q. If your CAN bus interface is something other than CAN0, please change it here. It must be an active CAN bus interface on your host system. If you don't know how to configure that, that's kind of outside of the scope of this particular guide. But if you need help with that, you can ask me in the comments and I'll, make a video on setting that up. At any rate, we're going to go ahead and press enter here. We're going to get our bootloader ID. In my case, I have 2 of them. I have one for application Klipper. That is the ID of my Octopus Max EZ. And then I have the other one here for the application Catapult. which is for the EBB36 Gen 2. So we need this value that I've highlighted and this value only. From there, we're going to copy this next command, paste it into our terminal, and then at the end where it says -u, make sure there's a space, highlight the UUID value here, copy and paste it. So it should look like this. And once more, if your CAN bus interface is something other than CAN 0, please update it here to whatever your interface is. From there, we press enter and we wait for it to connect and to flash. Once we flash, we should see programming complete with a verification complete. And then we'll have an SHA signature here. And with that, I mean, that's it. We've got catapult flash, we've got Klipper flashed. And now all we need to do is unplug and replug in the EBB36 Gen 2. And now we're going to get into the Klipper configuration. As you can see here, I've got my EBB36 Gen 2 that's installed on my A4T that we built in the previous video. And we're going to go right ahead and get into configuring Klipper. Once you've navigated to the IP address of your printer, we need to go into our printer config. If we head over to the BigTreeTech GitHub page and then go into the EBB repo, go into the EBB36 Gen 2 directory, and then we can pull up the sample BigTreeTech EBB36 Gen 2 version 1.0 config. This does give us everything that we need to configure our EBB36 Gen 2 in our printer. And they also give you the correct pins that you need for your extruder motor. So you'll have these three pins here, the step pin, direction pin, enable pin, and then down here under the TMC 2209 extruder section, you will have the UART pin. So essentially we're going to copy and paste these values into our main Klipper config. As you can see, I've got this already built out for my Mercury 1.1 printer that I'm tearing down and rebuilding into the Nebula. Just a couple of things to note here. We want to take that UUID value that we had earlier, and we want to add, if you don't have already, we want to add the section for MCU. You can call it whatever you want, but I call it EBB CAN, just to remind myself that I'm running the EBB in CAN mode. You can just leave this as like MCU EBB if you want. And then from there, we're going to paste in our CAN bus UUID. This is the value for the one that's installed on here. But for testing, my earlier one was the 100B1, etc. number. If you are operating this EBB36 Gen 2 over USB, then you will need to configure it like this with this serial. And then /dev/serial/by ID. And you can get this value by simply typing in ls-l dev serial by ID. You press enter. And as you can see here, my beacon device is listed. I have that hooked up just so the Klipper firmware won't fail to initialize. If you are using this in USB mode and assuming you did everything correctly, you should see a second value here. You would want to copy that value and then paste it in as a serial device instead. So from there, I know that I've got my CAN bus ID for the device that's installed on this toolhead. So pretty much this highlighted section is what we need to configure in order to get our A4T operational. As you can see here, I've already got the values added where they need to be. These are the pins that should be on the pinout diagram from BigTreeTech but don't exist. Whatever you named your EBB device, your MCU device up here, that's what you need to put down here for these values. So the first one is the step pin. That is going to be PB14. Then we have our direction pin. That's going to be PA8. Our enable pin, which is PB6. And then, of course, we need to set our heater pin, which is PB4. You want to set your sensor type. In my case, it's a PT1000. If you're using an NTC, you'll have to get the value from that. Generally speaking, I believe you'd put in here generic 3950. And then for the sensor pin, that's going to be EBB CAN PA3. Moving on, we're going to set up our TMC 2209 extruder UART pin, which is EBB CAN PB3. Down here, we have our filament switch sensor set at PD0. And then we have pause on run out true, yada, yada, yada. our 2-part cooling fans, PA5 and PD3, and then our fan configuration, multi-pin, and then these part cooling fans here. Last but not least, we have our hot end fan, which is PD2. We set it to the extruder, heater temp, minimum temp is 50, so it'll kick on anytime the temperature is over 50, and then we want to run that at full speed. At any rate, this is the config that we need to get our EBB36 Gen 2 up and running on our A4T toolhead. We click save and restart once we've got everything configured for our printer, and from there, we now have a working tool board. So the first thing that we're going to want to do is test our part cooling fans. We can simply slide that slider to 100%. And as you can see, I'm going to go ahead and switch to my overhead camera view. As you can see in my A4T, I've got one fan working here. Generally speaking, you don't want to touch the blades of your fans. I'm just showing it as working so you can see them. Both of these fans work. So we can go ahead and turn those off. We have our hot end fan reporting at 0% here. And then we have our extruder temperature reporting at 24.4 degrees. So if we go ahead and set that to 100 degrees Celsius, it's going to automatically turn this fan on. And this is our hot end fan that cools down the heat break and keeps filament from melting inside of the heat break and prevents all your plastic from melting. So far, we've confirmed that all 3 of our fans work. And now we're going to test out the extruder. So I've got a little bit of white filament inside of my A4T here. And what I'm going to go ahead and do is set the temperature to 210 degrees and wait for that to heat up. While we're waiting for that to heat up, we can go back to our desktop view and we can see that our toolhead runout sensor is detecting filament because we have filament installed. Again, refer to my previous video where I built the A4T for configuring and setting that all up, as well as all of the additional hardware for that build. At any rate, we'll go back to our overhead camera here, and now we are at 210 degrees thereabouts. So we're going to go ahead and start extruding some filament out of here. Right now we have our extrusion rate. I'll go ahead and show you. We have our extrusion rate set at 100%. Pressure advance is 0.04. Obviously, I'm going to need to configure this later on. Our smooth time is 0.04. The filament length that we're going to feed through here is 50 millimeters, and our extrude rate is 5 millimeters per second. Once we get my printer built and everything like that, I will go through and tune these values to push this thing for absolute maximum performance that we can. At any rate, we go back to our overhead camera and we will start pushing some filament through here. And as you can see, our extruder motor kicks on and we are successfully dumping filament all over our cartographer surface scanner board there. So here we go. We've got successful pushing of some filament. We can see up top of here. We'll watch as the extruder pulls in filament and kicks it out the bottom here so we can see it coming out. That being said, we have successfully flashed, configured, and tested our EBB36 Gen 2. And I must say that this is a welcome upgrade to the Gen 1 versions, minus the discrepancies and issues with the documentation. If you like my content or find it helpful in any way, please consider commenting, liking, and subscribing. It will go a long way to helping my channel grow. Thank you for watching, and in my next video, I will begin building the frame for my Nebula 3D printer. So stay tuned for that and see you next time.